Hello, everybody. Looks like we are live. Okay, so I actually have not decided on a topic yet, which means that you all watching it live get to decide of my few options. One, I have my little Nintendo editor over here, and let me show you how this works. You pop open, it loads the Final Fantasy 1 ROM. You get to pick songs, you can play them, and then you can do various edits to them. And we'll look at this and, see about, I'll just discuss how it works. Maybe work on some of the features. I haven't really decided yet. But you get a whole bunch of fun little things. Or the thing I was just working on the rest of the day today is this little text layout program. And this is going to replace mini GUIs on Linux text edit thing. And I've got the basic functionality working. And you can do things like select stuff. We can just, continue hammering away at this, or if there's something else that people want to come up, go ahead and drop me a note and maybe I'll do it, but I'll probably stick to one of these two just because they're relatively prepared. I have the files open here. So what's your preferences, folks? Well, so far, having heard no preference, I suppose I'll talk about the Nintendo program editor for a little bit. So this program is somewhat, it's very specific to the one game, Final Fantasy 1. And that, the way it works is somewhat specific to the Nintendo Entertainment System's hardware. So, up first, we do have a vote for Nintendo, so good. First thing it does, make sure that ROM exists, because it's going to load that and it'll pull some data out of it. And this is called the INES format, which is a dump of the ROM from the game, plus some meta info. So a Nintendo game, the cartridge itself would include extra hardware that's necessary to do a number of, oh dear, I'll come back to that. It does various options. The Nintendo runs on the 6502 processor with its 16-bit address space. But let's say you wanted to have more than 64 kilobytes of RAM mapped to it. You can have an outside chip called a mapper that's going to swap out various ROM banks as you go. Or you can put on additional RAM, which the Final Fantasy 1 game did. It would have 8 kilobytes of RAM on the cartridge to supplement the 2 kilobytes on the Nintendo itself. And that has a battery backup, which lets you save the game, or during the game, you can go ahead and use it. Chat is saying the mini GUI would be more directly useful. Well, good news, this is a mini GUI application, so I'll be talking about that. But the Nintendo ROM has a dump of all this data, and then it tells it which additional hardware needs to be emulated. And part of that program, and part of the hardware, is audio stuff. So the Nintendo would map to the addresses about 4,000 in hats, a handful of audio registers, that's called the APU, for audio processing unit. And you would put various values in there, and then that system goes through and generates a tone based on that sound. And if you wanted to create Nintendo music outside, you need to be able to emulate both the 6502 processor itself and the APU hardware, and possibly a little bit more. But first thing here, this is the NSF file, which means Nintendo Sound Format. That's basically a stripped down ROM that takes the program out of the full game and creates just a little bit of just a stub to play it. So it starts off with a magic number, and then you have to put some addresses. So which uh, address should you load it into? What should you jump to? And each frame through the game, you might change the values in those APU registers, and it'll continue creating that sound while the CPU does something else. But you've got to keep refreshing it if you want things to change. So there's programs that does all this. And this is all metadata for that file. So I'm taking the original Final Fantasy 1 ROM and creating a little Nintendo sound file format in memory to play that. And I ripped some programs out of it. So there's a fair chunk of just magical numbers in here. Oh, where did I put it? So I worked on this program last December around Christmas time, and I haven't touched it much since then. So I'll have to come back to how I did it. But yeah. And these are all magic numbers that I just got from analyzing the ROM. And there's a guy on GitHub called Ruppe who did a full disassembly of the Final Fantasy 1 game. And he also wrote the Final Fantasy randomizer, which is how I came to know a good chunk of this stuff. And he did a lot of work in figuring this out. Then I went in my ROM and just pulled out some magic numbers to pull it out. Let's see. Yeah, so the first thing an NSF needs to do is to jump over to it has an initialization stub that's 6502 code. So I just wrote a little tiny, this is what it does. You want to, which track do you want to play and where do you need to go? So I just took that, wrote out the machine code bits, and I'll copy that in when I run it. And then all of this is referring to stuff that the code inside the Final Fantasy 1 game is going to run. And I'll come back to this in a moment. Going back up to main, now that I have one, I create a player. There's a program on the internet called Nosefart that has all this stuff built in. So instead of me writing a whole new emulator by myself, what's the file called? Well, you can see here in the list of files, it's a C program. So instead of me rewriting all that to D, I got lazy. I just compiled it in C and linked it in with some extra in C stuff. That should be over here. No, that is... There it is. So I just used some of my extra in C to go ahead and call into that, because I didn't want to spend the time writing a full emulator when I only have... The truth is, when I do little programs like this, I'm lucky to have a week to spend on it. So I'm going to cut corners and get it done. So this takes the C program and drives it through my D program. And what happens out of the emulator is it's going to give me a frame worth of PCM data, which right here, fill audio buffer, is going to do that. So if I need to change games, I want to do that, or change tracks rather. I want to do that through in between a frame without breaking things, hence the synchronized here. And then the APU is going to run all of this. So what this does is it fills up the buffer with sound data, and I reduce the volume just as I can. And then this fills up a buffer, which my simple audio.d library is going to run. So back over here, I want to go to, I create an audio output thread, and this all comes from my simple audio.d app. Let me pull that up. So this is the documentation for this system, and it has a number of features that will be coming through here pretty soon. Up here is the audio output thread, and this is the main thing I use. You construct it back to the code. You just construct one, and then you can start issuing it commands. And it's going to do a number of really cool things. And then this MIDI output, this is hard-coded for my Linux bots, but I think it'll work on Windows anyway because I ignore that thing. So we'll see that momentarily too. But the reason I open up both is that the Nintendo is going to send me waveform PCM data, and then I use MIDI to preview things. And we'll see how that comes together. So now, let's open the program and take a look at it. And here is my basic UI. And right here you see the code that starts to create it. MiniGUI has a number of basic classes. MiniGUI has a number of basic classes. I'm actually going to mute that tab. So you have the basic classes like class menu that you can create in an object-oriented fashion. And you have a little bit of code generation because it's D and I can't help myself. And so one of those is putting a menu. So I put a UDA on it and I write the function that implements whatever I want the menu to do. And I can put various things like these accelerator hotkeys. And you can even take, here's a fancy one. Notice this function right here takes an argument and it takes a file name. So let's say I go to track, import from MIDI, and it creates all this magically, and it knows I want a file name, so it's going to pop up my regular file browser. And I don't have to write too much of that code. And here's where my MIDI starts to be used. How fancy. And I can actually generate quite a few dialog boxes just out of function parameters. So we will be seeing this again in a moment. But yeah, if I go save ROM as, it keeps a file name. And you'll notice that I did a template here. And this is an alias to a string, so it will remember that in between things. So I wrote cool.net. So let's say I wanted to save it like that. If I hit it again, it actually remembers that file name because I passed the alias in here through the type. So these are all just a few little advanced mini-GUI features that I haven't really demoed very much, so this is probably new to many of you. And now, let's load up a song. Oops, my chat window disappeared. There it is. And now, this right here is another mini-GUI widget. Most of these are pretty basic. You got a drop-down list, you got this, and then there's a thing. So let's open that file. ff1, yeah. Oh, why did I call it such a complicated name? There we go. So to create a window in the mini-GUI program, minimally you just do new window. But if you want to add some more stuff, you can create them as a child. So this is the one internally. A lot of times I'll do the most specialized things up top and kind of work my way down. So envelope chooser, that's different. There it is. So I create, this is the main user interface. First I create a main window and you can see the title, which is reflected right there. And then I have my song chooser, which is all basic object-oriented stuff, nothing special. I have my checkboxes. This will let me turn on and off different sounds as it plays. So let me start playing this. This is the full sound. And it gets a little bit empty as you switch things around. this song's not really great for demoing that. But still, you get the idea. The Nintendo is capable of making a handful of different sounds, but the main things you hear are the two square waves, the triangle wave, which is typically your bass, and then there's a noise channel, which makes you musicians would tend to use that for percussion. Final Fantasy 1, interestingly, does not use the noise channel in any of its songs, which is why it is excluded from this list. But if you were doing a generic program, then yeah, you probably want that too. And then I'd go ahead and create, this is the scroll message. So the scroll message widget creates the two horizontal scroll bars, and it tells its children when it scrolls. And on Windows, by the way, my redraw is a little bit janky, as you can see. The reason for this is Windows will do its own modal event loop when you're scrolling or when the window is open. And inside Simple Display, I have a custom event loop where you send messages to it. And I use that to batch up various operations. And the problem is when you're inside the Windows event loop, those custom events are only fired periodically. So it gets janky like this, and I actually need to rewrite that. If I load up the Linux version, I don't have the sound running on Linux, but it's the same program. You'll actually see it works quite a bit nicer because on Linux, it's all custom. I've written all of it myself. And now some people don't like the style I wrote on Linux, and there's this little bug up here where that text is cut off. But still, there's advantages and disadvantages both ways. But let's go back to Windows for now, because that's where my sound is coming out. So the scroll message thing will send messages to the window, telling it when it's scrolled. And where is that? This window. And then as a child, I add this NSF widget, which is a custom one. And then over here, I have some events. But let's go back over here. So this one lives inside the scroll. And I set the event listener so when the... What is clipped at the top? Steve's asking what was clipped at the top. I believe that was on the Linux program up here. So these are the channel selectors. Just like on Windows here, they're not clipped. Over here, it's the checkboxes to choose which channel is displaying. I have a small bug where I didn't respect the padding on the Linux program, so I need to go fix that. But, you know, it still works more or less the same way. And you might notice that Linux is throwing an exception because I did not have MIDI set up right now. So it's telling me it can't open that device. That's because I'm not running the program. Not on Linux, on... What? Oh, yes. Asking about the O- stuff. I will come back to that momentarily. So this is your basic mini GUI event listener, and it's based on JavaScript, and it's actually based on JavaScript to such an extent that under the hood it translates these into strings. So each event has a string, but I've been adding more strong typing to that in the last year. That's actually why ARSD hit 10.0, because I decided to break the event listener ever so slightly to add some strong typing, but both ways still work. It says when it scrolls, I need to move my stuff. When I put my mouse down, I can drag and drop some various things. When the mouse moves, I'm able to continue dragging. This changes my background. Many GUI, you can either draw stuff yourself, or you can do this kind of CSS-inspired style class, where you write a thing, you override it, and then you mix it in. It does the magic. And then if you're writing a container, you're responsible for laying out your own children. So this is all of this is showing what's inside this box. And what's inside this box are the commands pulled out of that Nintendo ROM. So Steve was just asking, what's all this stuff? This is a command to change the octave. So this is saying, I actually need to go a little bit more into to the file format to explain some of this. Oh, where is that one? Alright, so borrowed from a disassembly. On the Nintendo, you had very little memory. The entire music track for the game Final Fantasy 1 fits in about 4 kilobytes. And it managed to have, I think, 19 songs. So however many this is. And each individual song is thus more or less 200 bytes of data available. So to make it fit, they did a number of fancy little compressive tricks. Each command in that is an individual byte, or there's a 2-byte thing for jumps, where it packs things into the individual bits. So a byte with this means play note, but you'll notice that if you only have a handful of bits, you're not going to be able to cover the entire spectrum of music. Let's say you want to go a couple of different, from a low note up to a high note. You got to be able to change that. So it uses a little bit of state, which is set by the octave select byte here. You got 4 octaves you can choose from, which is going to transpose this play note high or low. So as this song goes, it starts off over here at octave 0, and then as it goes on, that's 0, goes up a little bit, that's still 0, now it goes octave 1, then it goes octave 2, and so on. So each one of those command bytes is going to change what these bytes down here do, and the program kind of expands this for you. So each one of these would be packed into 16 different values, but since I know the octave has changed, my program is going to multiply it by that number to bring it up and down a little bit. Similarly, the tempo, rest here, rest, I think this song should, no, maybe it doesn't. One of these songs will demo that. There you go. What rest does, it just mean continue delaying that channel. So it'll keep doing whatever it was doing previously. And if we take a listen to this song, so you can hopefully hear that little bass track where it's just playing dot dot, and that's using that to rest a little bit. But what exactly happens if for the sound if you leave it alone? Well, that's based on this right here, envelope pattern. In sound synthesis, each sound has a different pattern of volume as it goes. So let's say you hit a bell, it's going to start off a little bit loud, then it starts ringing, and it's going to get quieter as time goes on. Or if you're doing flute, for example, it's going to be much more steady as long as you continue the airflow. So these are different timbres of the musical instrument that are going to sound the way they sound. And they tried to create this in the game too. You got envelope speed and envelope pattern, these two control bytes. What these do is change that, and I have a window somewhere. There you go. This is another window that just pulls that data out of the ROM and displays it to you visually so you can get an idea of what to expect. So if you had a pattern 0 command, it would start loud and then go a little bit quiet. 1, and so on. This one starts, goes down, then back up. And then the envelope speed decides how quickly it goes through this pattern before it gets to the sustain at the end. If it ends it quiet, then as this one, what pattern is this? This is pattern 12, which is this one. Or is it that one? Well, I can't count. Since it's 0 base, I think it's actually this one. But either way, you'll notice that it ends down at the bottom of the line, which is why it kind of does that little sound and then it goes quiet. Again, taking a listen. So you actually have a rest. If you didn't, you would get something very, very different. I think this one will. You'll notice that this one was a rest command, but the sound kept playing. And I did that because the envelope pattern would have been one of these over here that actually keeps the volume up a little bit. So half of writing this program was trying to figure out just what all of this does, and the help from people online who's done the disassemblies and analyzed it a bit more made it a lot more doable than it was. But the ultimate idea of this is to be able to actually edit the programs. So let's say I just did a drag and drop. Now let's take a listen. It sounds horrible because I pulled that up, but I didn't change the octave command. And so it really changes all these things on you. And each one built into the bytes, you've got duration, and this is a lookup table because then again, you're trying to cram all this data into a byte. So you've got 16 different durations, and the different durations are set by, let me turn that back on. The tempo command, which changes which lookup table it uses to find how long each note is supposed to be. Let's say I change that tempo command. Well, first let me play it so you if you don't have the song as memorized as I do. That's what it sounds like normally. Now let's edit that. I only changed the one channel, they're all independent, but this is channel 2. You can hear it's a little bit quicker now. Let me click that. Let's change it to pattern 7. There is no pattern 7, so I just broke it and my program threw the exception and crashed on me because I did not do error handling. But let me get back to that. Let's go tempo. This is number 4. Let's just go to number 2. Now it's quite a bit slower. So there's a little bit of reason to the game that once you get to know it, it kind of makes sense and you see where they're going. But this program, let's see, it's like a miniature thing. Yes. Yeah, to understand what was going on here, I had to write a few helper programs myself. And that's why I have that little pop. I always talk too much and I don't think the baby left me her water cup. Maybe I'll go ahead and steal some from her. Just a sec here. But there is a method to it. Now, the really difficult part is this program is supposed to let you change the songs in such a way that it sounds kind of cool. It's not supposed to just sound butchered when you make a few edits. And I'm trying to make it as user-friendly as I can. And that's the whole point of this inside visualization. When you play it, there's these bars that represent what the channels are doing. Now, when you look over here, you see this one just kind of bounces back and forth. Why does it do that? In order to cram more data into it, they have loops. You can actually loop the same stuff over on the independent channels to compress data into that 200 byte budget they have available. So let's go to the ending theme. That's a good one. This one runs for almost 5 minutes in the original game. And this is... Where is the loop command? I think it's coming up next. Yeah. So I represented the loop visually by these boxes right here. So now these are going to keep going. Keep going. This one's too long. This isn't a good demo. But it's going to play this section of the song 4 times. And then it will continue on to this section of the song. And if I think if I edit that, let's make that loop only once. But now I'm going to have to wait for it to get back. Because anytime I edit the song, it has to start from the beginning. Just because there's so many state variables that I couldn't keep it steady in there. And I didn't want to corrupt it any more than I already was. But now we should be able to get something happening. It might crash because I didn't finish the UI. Now if I was smart, I'd spend this live stream actually improving the program. But maybe we will. Maybe we will. Oh, where does this end? But you get the idea anyway. So let's take a look at importing from MIDI. This is where things get a little bit fun. So let's say I have a song. Let me stop that one playing so we can listen to this one. So I just pulled up a song and I forgot which one I clicked. I'll do it again. I'm going to load Final Fantasy III's Battle Song. That's a fun one. And I loaded the MIDI. And now MIDI loading is something that is again over in my gigantic ARSD library. Basically everything's in here. If I've ever needed it over the last 15 years, I wrote it. But yeah, so written in August 2008, ported to D in September 2017, to give you an idea of how, when I say I'll get around to something, I'll get around to it, but it might take me 9 years, so don't hold your breath. But what this program does is it understands a MIDI file format, and it presents a way to work with it from D. And I tried to abstract everything into a stream of data that you can just feed into a MIDI device, or you can put into a filter, or you can put into, whatever else you want. I have a handful of really cool MIDI programs, including one that can pull live stuff and render it to a staff, which is on my Linux bots. But anyway, by using that program, I can pull up the duration and the note from each channel, and I'm filtering it down. And now let's say I want to feed it into the MIDI device. I forgot what song this was again. Oh, Final Fantasy III Battle. There you go. So this is just playing out of the Windows MIDI player, but now you get an idea what this sounds like if you can't eyeball it visually from this display. Now let's say I want to set that to square wave number 1. A lot of magic just happened over here. Now it's part of that Nintendo data. And let's take a listen and hope it's not butchered too badly. So you can kind of recognize the song, but it obviously sounds very, very wrong. Why is that? And this is the big challenge of this application. We have to use the lookup tables that were written by the composer of the original song and try to adapt these other things to fit them as best as we can. FF1, NSF, where's MIDI import? There it is. So this is what this does. This function loops through those lookup tables and tries to find, this is a duration for the thing with the least amount of error from the original thing. And if it finds one, it commits it. But it also tries to minimize the amount of space because that 200 bytes does not last very long at all if you just naively dump stuff in. So it accepts an amount of error to avoid having to change tempos over and over again. The more you can reuse the state, the more you can fit into the song. And over here, this is using that MIDI over here, playback stream. That's exactly what I'm doing here. This is a range. So I can just for each it in D, and I can get a look of what things are happening in the amount of time it's happening. So if it's a note on, and MIDI, by the way, the note on command is also sent when a note is turned off because it has a velocity. Over here I have a cute little MIDI device. If I hit that, that's note on, 128 or something because I hit it kind of hard. Then when I let go, this piano sends a note on 0 because I just let off. So you have to remember to check if the note velocity is 0. That is a different thing than if it's turned on at a different speed. And then you also check note off. And I create a little mapping that tries to find how long this is going to run thanks to a buffer, and then go back and just try to adjust for error. And my program does in some places it does an okay job. In other places it doesn't. Let's try, where is that Castlevania song? Do I not have it on here? I don't think I do. Mystic Quest isn't a really excellent battle theme. Let's take a listen. So again, this is what it's supposed to sound like. Out of the MIDI. Now, we'll go over here and play. So it didn't do a very good job actually making this thing work. But it sure did make an effort. And you can hear points here. It's not too bad, but there's other points where it is quite bad. And that's my error checking algorithm trying to catch up. And by the way, it just looped there because in order to compress the data, I'm trying to use a thing so it says roll up loops, where it just brute forces running over trying to tell if there's any repeated data. And Nintendo songs, because the music composer was actually, they understood the limitations, they would try to write it with this in mind. And you can do some really clever things. You might have channel 1 loop and then have channel 2 play a different part of the chord, so your ears will hear it as a slightly different note, even though it's the same. Well, once you get into Final Fantasy Mystic Quest, which is on the Super Nintendo, they had a lot more space. I think the Super Nintendo has 8 voices it can play. It's phenomenally more complex than the old Nintendo. So the composers, they use that ability. And if I'm trying to import a Super Nintendo song into the Nintendo, I'm going to have a really hard time hitting it. So you might have a loop that starts off and it hits a high note, then it plays most the same thing, but it hits a lower note on the second iteration. I can't express that through a simple, naive loop. So my program at some point will have to learn to do something more cool about that. But nevertheless, some of these really do sound pretty good. I want the... I can just play with this stuff. One of the reasons why I have a hard time finishing these programs is once I reach the point where they have use to me, I'll just sit around and goof off. So I'll just play with this instead of going back to the hard problem or trying to solve these things. But Dragon Warrior 1, that's a Nintendo game. Oh, come on, play. You know you want to. I think there it is. That's what it's supposed to sound like. Let's import it. Why does that sound so? That's way too slow. I'm gonna hand adjust that. Oh, I know why, because I didn't clear it. Let's just clear them all. There you go. And again, the composer knew he was working for the hardware, but remember again how so much of the Nintendo has special lookup tables for each game. So when he was writing the Dragon Warrior 1 song, he was working with a different program than the people who wrote the Final Fantasy 1 songs. So while the hardware can obviously do it, my program hit something and crashed in there. Probably went over the line. But when you're working with the same lookup tables as the other game, when you mix and match them, it's really difficult to get everything to fit. let me try to play. Oh, the battle song is the longest one. So let's I don't even know what I want to do. There's a Super Nintendo song. Where is... And now my viewer on this isn't exactly ideal. But now if I set square wave 2 to this one, and let's say I go up to, let's set that to the triangle wave, and if all actually works out, we might be able to hear all 3 parts of that song. But I bet you we won't. Let's listen. Those of you who've played Final Fantasy VI might recognize this, but it's quite butchered. And you see it trying to loop because it tried to find some repetitions. And another thing that the composers would do when they have more space, you would actually have a nice introduction to the song, and then it would go into it. Notice how most of the Nintendo games didn't really do that. You might have a do-do-do-do-do-do, but that's about it. And fun fact about that little ditty, listen carefully. Next time you play Mario 1, when you pick up a mushroom or you do the end of level, those are the same songs just played at a different tempo. So there's a whole bunch of things they would use to reuse data. Mario 1 fit in, I believe it's 64 kilobytes of RAM. And to do that, they had to compress a lot of data, and they would do that through a huge amount of repetition. But it's really cool how they'd actually pull it off. I'm always impressed by it. But part of that is also the design, where you just get into it. You write a strong melody, and then you use that strong melody. And that's why these songs were so memorable to us. But it's also really, really difficult to automatically do things in that style without hand edits. And as you've seen with me goofing around here, doing hand edits is not easy to these files because so much of it is based on maintaining a little bit of state or working with what they had. And we're not all in the position of being able to rewrite that, especially if you're trying not to butcher the other tracks in the game. But now, just to show how this program actually works, let's take, this is a chrono trigger song. Let's take a listen. Hey, that actually sounds really good. Wow, that you see, my importer, it doesn't always do a bad job. This time it did a good job. But it's the exception rather than the rule, which is why I haven't really released this program. But now, let's say I want to save the ROM. And over here, I'm going to play it. Because I want to show that it actually can overwrite data that we can run. So we go over here. And hey look, I replaced the song. And the rest of the songs are still there. I haven't butchered any by overwriting. So that's really the challenge, trying to do that so you can do a replacement without breaking everything else. And sometimes it does succeed. Let me catch up on chat over here. Anyway, now that I've laid this down, let's try to, I don't know, actually write some code. So one of the things we noticed, this is all debugging output because it's trying to reduce the size. And like over here it says after rolling the loop it still took a kilobyte, which is obviously too big when you have 1/5 that. So alas. So I actually don't know what exactly I want to code in this today because there is no easy solution to any of this. So just kind of showing off the application is a lot more fun than sitting down and trying to debug it. So let's, oh, I really do need to make, wait, what just happened there? Ooh, that's a bug in little mini GUI, so it's taking a, it's scrolling the other one too. Oops. Oh well. So I want to go back to one other, I double clicked on this and it popped up this dialog. Let me show you the code that generates that. Double click. So this is the double click event handler. And this called the dialog function out of MiniGUI. And you see that there's very little actual code here. It takes a strut, which is an FF1 music command that is from over here, I believe. There it is. It's got enums, it's got a little bit of data, and it's got a handful of methods. And you might recognize this. First you get type. This is a dropdown. See, it's all enum members. And then it sees that you got a byte argument, so it takes a numeric input. Then as it goes down, it sees that there's a method called instruction length. You click that, and nothing much popped up. But it's trying to call those and display the results. So let me go ahead and demo some of this, just as, I don't know, I think this is a cool feature of D. Dialog. So this is the implementation of that. We have a new automatic dialog, and this is the class that actually does it. So the function here, it takes a delegate, which takes a particular type T, and this is implicit function template instantiation. Let me go back to the usage point. So you see, I didn't actually put the thing, give me a sec. I didn't actually put any template instance here because it figures it out from the argument of the given delegate. So that's all that. And this manages to call this function, which then calls automatic dialog. And this is a pretty fancy little template that takes type T, and this is all just set up. I'm putting it in a layout. I'm adding OK cancel buttons. And where data controller widget. And by the way, whenever I do these automatic things, my first plan is to just do it all in one piece, but then I invariably want to customize something. So if you have this humongous template that's doing all this magic, but then you need a little thing changed in the bottom, well, what are you going to do? And that's why I have all these decomposing functions that you can do to combine it. Oh, where is it? Oh, there it is. Add is another implicit function template instantiation that then calls out to this data controller widget. And this is the class that will actually do the magic. So you go down, and what this is doing is reflecting over that structure I gave it. And this is quite a list, including one of my beloved comments, where you all know that I love the D language. I've used it for a long time, but it's got a handful of bugs. So when I hit them, you work around it, and then you say something, just to make a note to myself. What is this bug after all? I'm kind of curious. Come on. By the way, if you watched last year, you see I wrote a custom browser too. I don't have that installed on this system, so you get to see stock Windows at Edge. Oh, that's why. Because it's private. Anyway, so I need to skip the private thing, and then you go down, make sure that it's actually public before I go nuts. But now, this, again, it's about decomposing so you can use some of these functions independently. So this creates the control for that particular data type. And then you have to go through and wire up all its events. So if it's a button, it's going to be triggered to call a function, which it does through a little recursive call here to call it again. If it is a Boolean, you do a checkbox, strings, etc. And it puts all that data into the strut. So back at the usage point, by the time I call this delegate, this strut is fully populated with whatever it is I actually did in the user interface. And this is probably my favorite thing about D. If you've seen any of my website things, I do the same thing. You take a function, it looks at the parameters, creates an HTML form for it. So all the stuff just magically works whenever you go in and decide to actually call it. Just double checking the chat again. Okay. It looks like we do not have very much talk, so if you guys have anything, always feel free to pipe up. I know I digress very easily. I've written no code in this live coding session, so by all means, go ahead and call me out if you want to. But as a result of all this, I don't have to think about writing too much UI code because it did it for me. And is this a great UI? Of course not. But is it a passable one? Yeah, it is. So let's go back over here and see why did that function not call? So this is, if it's a function, then it does a button and it adds this handler. So what happens over here? Make automatic handler. I look at the parameters, figure out what they are. Oh, that's because they were 0 arg. Okay, so this is the same function I use in the menu. And a quick refresher. You know, save ROM, and it looks at this parameter and it creates a dialog box to ask you what that should be. So when I go up here, since this has no arguments, there's nothing in this dialog. And then the return value, back over here, the return value is going to be discarded. Gotta love these hacks. If the name starts with save, it's a save dialog, otherwise it's an open dialog. Oh, I love it. But now, I pop open the thing based on the parameters, and the return value is just sent down, cast void, it's ignored. And so if I wanted to show that, I would have to write a little bit of code to do it, or at least just toString. But this is the downside of making reusable functions. In a menu, you don't really care what the return value is. In a dialog, you probably do. So I'm going to have to do something to modify that. But there is one little bit of magic. A void function. This returns void, so obviously I don't care what the return value is. This one returns int. That indicates that maybe the return value matters. So let's go ahead and do some implementation of that. Down here. I'm just going to take, so this is something that's a little bit annoying. If I were to say auto ret equals this, it is not going to let me compile. Oh, don't embarrass me and actually work. So generally speaking, it'll complain that you can't have a variable of type void. And it must be because I handled the void branch. That's right here. So is it void? I think that's the one. Let's go over here. There you go. So that was a void branch. So now it's saying that you can't create a variable of this, and it's going to puke up your code every single instance of this happening. So let me go back down here and just ignore the return value for this, and I'll come back to it later. So now up here, this is I'm a little bit distracted because I am doing 100 different things. Anyway, this is the void branch, so I'm going to ignore that. And then down here, this is the non-void branch, which is why I should have kept that. Ret equals that. And I'm just going to... I actually have a policy not to import standard.anything throughout the entire branch of this code because it's going to hurt my compile time. And that's hard to say, but it's true. If you use it twice, it doesn't really hurt you. If you use it once after you've been using it 0 times, you notice about a half-second change, and that half-second bugs me. But anyway, I just pop up a message box that says to string ret. Let's see what happens. I want to compile it over here. It should let me this time. And then whoops, that's the wrong window. Copy it back up to Windows for me, because I'm too lazy to install a decompiler on this computer. It's not its job. Now we'll go over here and run it. And that was in this. If I hit this, it called the function and it says it's length 1. If I want to get the bytes out of it, that's what it would actually put in the ROM. So now I have a little bit of a... I can call those functions and inspect the return value a little bit magically here, which is a nice little feature indeed. What else do I want to do? Let me come back to this. Add a title so it doesn't say error. But I will come back to this in a bit. So what I really enjoy about using D in this way is I can take one source of data, a strut definition. I can create a GUI application out of it. I can create HTML out of it. Or you can wrap it and create script bindings out of it, which I don't have prepared here. But if you import my script.d and you just assign it to a var, it's going to do that for you. It's going to create a little scriptable function out of it. And on the Discord earlier today, there was talk about CLIs versus GUIs, and I said, if you look at the application as an abstract model, and those are two different ways to interact, you're not building one on top of the other. You're building them both out of the same definition. And that's exactly what I'm trying to do with D in this case. Let me pop into the... Okay. I never even wrote the help about. Oh yeah, these here, the hotkeys do not show up on Windows. But this is another really nice thing about this. Let's say I want to put a hotkey on checking out these patterns. I just put at F3, and now when I run the program, I hit F3. Now we can hear the different envelope patterns. And it's incredible how different they can sound. And by the way, I'm using F6 to start stop, which is, it's the same as clicking lat. And that works because I put an accelerator on that. And it's just the little things like this that make actually writing D libraries different than writing C or C++ even, because you can attach this data and do something with it. The difficult thing is to do this without making the code completely unreadable to the poor person who's not used to it. And if you look at this implementation, this could probably be prettier, but it is what it is. Now, that we've taken a look at all this, let's take a minute and write a new program from scratch. That'll give us, a little bit something new to look at that follows these same principles, but maybe easier to understand. Oh, let's head over to my DConf folder, and I'm just going to create a player program. So first off, the most basic program I have, you create a window and you loop on it. There you go. A window has successfully popped up. Now, let's go back and start adding something. So I'm going to want I want a menu. So I'm going to use that magic again. Where I go, menu, file. And by the way, this syntax here, it might look a little bit magical. Oh, file name. Let's put a string up there, which will be, this is just to remember what it is. And I think that's going to compile. Incredible. But you'll notice that by itself, D annotations don't do anything. They just attach data to something. You have to run a function against them to make them show up. And that's why I'm going to window.add menu and toolbar from annotated code. I think, let's see if my memory worked. No, I messed it up. It's something like that though. Add menu. Oh, it's set menu and toolbar. So much for my intuitive names. Oh, come on. Don't make me copy paste it. I know there's some people with their fancy completion things. That's not really me. Oh, it's only on the main window, that's why. So I did type it right. So we set a main window. And this is a ref argument, not a pointer. So as you can see, I don't actually use this every day. I gotta make that static too. There you go. And the reason that it needs to be static is a template is instantiated either in a context of another template or in some static global context. And if you're inside another template, it does a lot of copying of things, and you can really explode the size of your binary. But if you're at a top level, you gotta have references available. This is a runtime thing. And Steve is saying, it reminds him of the Apple API is my big name. Yeah, it might not be like the fancy name, but when you read it, what do you think it does? It probably sets the menu and toolbar from annotated code. And I kind of like it just being that simple to read. But going back here, this has to be static because an alias to a top level template has no associated context pointer. So it can't refer back to the object menu without you passing it one. Which you can pass one, but not like this. So I had to make it static. But anyway, we now have a thing. So I click my menu. I can open up a file. So now I've got the basic functionality here. And now let's go ahead and import simple audio and create an audio output thread. I'll just use true. So you can't have a default constructor in D. And since this strut needs to do something on its constructor, there's always an argument. And the argument can be a string, which is a device name, or you can just use a bool. And if you say false, it creates a dummy output that just doesn't do anything. That way your code can compile if you want to turn the sound on and off. Or you can set true, which just uses the default thing. But I could just as well have said default device like that. But now I have a thread and it's running. And so I can go over here and audio.play mp3. I think I can call it file name. I might embarrass myself here. Nope. So now I need to go ahead and find an mp3. I'm sure I have quite a few. And I'm playing this out of my Linux bots, but I think you can hear it over the mic. That is a song from Metal Gear Solid. So now we have a little audio player. But you probably want to do something a little more interesting than that. We want a controller. Let's go back to the documentation. These various functions, which all come out of the implementation, and I use play mp3 file name, it returns this object right here, sample controller. And I'm going to use this to keep track of what's going on as that plays in the other thread. And I've actually recently added more methods to it, so I think you'll see that over here momentarily. So we want to go keep a reference to that. And now let's add a pause button. If controller.pause. Let's take a listen. Oh, and actually, let's copy a file over here, just so I don't have to navigate through my massive directory of nonsense. Wait, which one sounds fun? I've got plenty of Final Fantasy songs here. Let's take the Final Fantasy VIII credits song. That's a good song. So now I'm going to open my file. And I pause it. And I don't have an unpause method, but hey, it just shows how easy it is to start adding stuff when you have your thing. So I want to talk a little bit about this whole block. This might look like it's attaching everything to one big menu object, and it's not. If you know D, this is exactly the same as doing pure a bunch of functions. It's just attaching the attribute to each individual function. And then the magic of recombining it into a single thing is done over here. Oh, there it is. So first I build a strut out of all those UDAs. That's what this ugly code is doing. But it's getting me into a runtime object that's easier to manipulate than trying to run through all of these reflections all the time. And then once I get the objects together, I use, and this is at runtime, it builds a menu and sticks it in an associative array. So if it sees the same name pop up again, it will go back and add it to that list instead of creating a new one. And then the separator, that's attached to an individual function, but it takes that as an imperative command as it reflects through it later. So, and of course, if you wanted to build your menus in the object-oriented fashion, you could just write out all this code. But why would you write all this when you can just write that and just focus on what you're trying to do instead of the plumbing behind it? So that's my view on this. So let's take a look at the master version of that sample controller. Oh, there it is. I have some more really cool things. I can resume, and I can change playback speed. I love changing playback speed. And you might be saying, can't you just create all this by yourself? And maybe I can. Let's try it. What happens if I say control sample controller? Just for curiosity, because I've never tried it with an interface. I don't think it's going to compile, but let's find out. Whoops. I don't. Wait, line 9410, isn't that what we just edited? It is. So there is a separate void branch over here. Static if is type of t return. Is it going to be void? Is ret void? In that case, there's nothing to do, you just call it. Otherwise, let's keep this to a little pop-up. And this, by the way, is something about D that actually bugs me. I wish you could have variables of type void. And when if you're watching discussions about new features and they say this is another special case and they're trying for uniformity, this is a good reason why. A great deal of decode is going to use one of these generic types at some point in its life. And the more things that work generically, the nicer experience you're going to have. Will it compile now? I have a dangling else. Who does that? I don't see a dangling else. You're lying to me. 9410. Oh, there is a dangling else because that static if is nested. That's not the only thing it's complaining about. What did I miss this time? Oh, I did it in the other place too. So, no, this is not going to work today. Maybe we'll come back to it later. But this by itself, no. But there is another function, and that's called the data controller widget. And let's try to add one. Window to add data controller widget. Since it starts off null, so this might not work, but again, you never know. You'd think that I've written my own code, I know what it does. No, I don't know what it does. Parent function T. It must satisfy the constraints of being a class, and it is an interface. This is another slightly annoying thing. Classes and interfaces are used mostly the same way, but the generic code, you test them separately. And there's not really one, is this a class or an interface? You have to think to write class or interface every time. But let's go back over there. 4004. Is it a class or is it an interface? Let's see if it works. Now what? Sample controller. Well, I don't need a pointer because it's an interface. So what did I miss? That must be down here. So now when I create, this function only exists to create the object. And the object is going to have to repeat some of its own magic. So if it's a class, if it's a dynamic array, or if it is an interface. Where are we? No, that's my text layout. Now what? Type void is there. 3858. Let's just go ahead and dive in there. So widget 4. Well, widget 4 isn't supposed to return void, is it? So what do we have here? If it's controlled by let, yeah, that's not supposed to return void. Why does it think it is? No, I do want it. So you notice that the return type here is auto. That could potentially be hiding something inside this function, which is wrong. And it's tempting to change it to widget because I know that's what I'm returning. But I'm not necessarily returning widget the base class. I might be returning a subclass of it. And in this case, it's actually important that I retain those abilities because down here, some of these methods are only available on certain subclasses, like is checked is only going to be on a checkbox. That's not on the generic interface. So you've got to be able to, and in fact, that's what this line is doing. This is testing if it has an is checked property, which the interface doesn't, the base class doesn't. So I've got to retain the derived class up here. So I can't just avoid that. Let's look at that error message again. And often DMD kind of spam stuff. I like some blank space to see where it is. But it says 3858, this.w. Yeah, it must be returning void. So now the question is why. And this is where some of this decode, there's been a new user talking about how ugly it is and how difficult it is to follow. And I sympathize. I think it's worth it if you do it well. But if you just kind of naively drop stuff in without a lot of thought, it can get ugly really fast. And this error message is one of those where it's a little bit ugly. So, controlled by, I don't know where that is. And since this is an attribute, it's hard to just say else assert 0 because the unreachable code error is going to reach you. So that's not fun either. But let's go down here. This looks like it might be something. And those of you who talk to me a lot say, I will tell you never use string of. There's one exception, and that is for displaying error messages to the user. Don't use it when generating code, but do use it when fixing things. I've got another. Okay, it's my 15-minute warning. I'm running low on time. But there we go. Now it's telling me I have a type of float, which is not supported in here. So let's add it. And float is the return value of several things on that interface. So I want to add the support for float. If it converts to a long, that's one thing. If I can convert to a const double, that will cover float. And let's just make it a line edit. That's good enough. But I don't have. I'm going to have to pull in Phobos in here again because I do not have a 2 internal that handles float. So let's just do it. I'll use Phobos' toString. Now let's compile it. Whoops, that's the wrong program. This is my other thing I was going to use. Okay. Question from chat. Why not use string of when generating code? And the reason why is to do with namespaces. Let me just run the program, see if it actually works here. It seg faults because it is it's a null variable at this point. So we'll come back to that in a sec. But why not use string of? So let's say I were to take one of these templates and I wanted to pass it my custom type. That's defined up here. Heck, I have menu right here. Let's say I were to pass it this menu object. Well, this is defined in this file, player.d. It's interpreted in this file, minigui.d. Does minigui import player.d? The answer is no. So now when you use string of, all it sees is the name menu. It doesn't know which module that came from, and it's going to get lost. If you saw Attila's talk earlier, he talked about using fully qualified name to kind of work around that. You get the fully qualified name, you parse out the module, you import that module, and this is a big source of bugs in a lot of code. It just doesn't work. What if you already have a name in your scope with that? How are you going to disambiguate it? Again, fully qualified name can kind of do it, but it can't fully do it. A fully qualified name might include a template argument. How are you going to disambiguate those? And it gets arbitrarily complex, and that's part of why that fully qualified name thing is so horribly slow, because it tries to do all that, but it doesn't really work. So what you do instead is you take a local name. So this is alias pp, and type p. Inside this function, if you pass me a player.menu, p is now that player.menu, and I don't have to import anything. So instead of trying to do p.string of, this is going to be a compile error. I can just plain use p. Just works. So not only is your code quite a bit simpler looking, it's going to work a lot better. The big time when you get in trouble is, let's say I want to return a function which is mixed in somewhere else. Then how do you refer to it? Because you don't have the local names anymore. And my answer is, don't do that. Just don't do that. Like, there's alternatives. Try to look into using one of them instead, and you'll have more robust code in the end. Okay, that was a little tangent, but where was I? Oh yeah, the null. So let's go back to simple audio for a little bit. Why did I make this private? I hate making things private. I'm just going to delete that. So to make it not null, I'm going to make it... my headphone cord is in the way of the keyboard. New dummy sample. And if you look over here, all that does is nothing. It's just an empty thing that that implements it. But now that it's not null, maybe it'll run? Hey, it did. And now it looked down through all of those various methods, and it created buttons that are going to call them. So now let's open my file. And can I pause it? No, I can't. And here's why that is. I can pause it from up here. So this is the other difficult problem. See, when I did the add data controller widget, this little controller it's a reference, but it's passed by value into this function. So now when I get down here and I actually am working with this thing, again, it is a reference, but when I rebind that reference out here, so I say controller equals play mp3, this function didn't get the memo. It's still working with the first one that was passed into it. So to work around that, I think I can pass a pointer. Do I dare to try? Of course I do. Let's see what happens. It didn't work. So now it's saying it needs to be a class or an interface or a strut. It does not work with pointers. And so I'd have to probably dereference it and then work with whatever is in there. So is that something I can do in the 6 minutes I have left? I don't think it is. Let's create a fake pointer. Can I do that? Ooh, I can. Here's what we do. I'll create a little class holder that holds the controller. Because I'm lazy. There's new holder. And now I'll set it through that. So now there's another layer of indirection through that helper class. So let's just see what the code generator does in that. Whoopsies. No, now it's trying to reflect into this class. It sees one of these and it says, I don't know what I'm doing. But let's see if we can add that. And I know when you look at me writing all this, you might say, this isn't worth the hassle. I could have just written buttons that did this and been done with it. But when I write all this, it takes me, half an hour to add it the first time. But then anytime I go back, it's going to work. And I do release these libraries to the public. So if you use it, if you find something that doesn't work, email me. I can add it in half an hour, put out a new version, and then everyone benefits. So it's not necessarily a big problem. But this is 3979. And I think that's the one I just edited. Yep, it's another type that it doesn't know how to use. So what if it is the type of T is a class, or as we just went over, if it is an interface, it works essentially the same way. I'm going to parent add data controller widget. Let's get recursive on this thing. And just return that thing. What happens? Need this for controller. Okay. Need this is something that pops up quite a bit when you're working with template alias arguments. So whenever you pass a template alias, it's not passing the variable per se. It's passing a reference to what it's going to represent. So now when I'm pulling up controller dot, this is holder dot controller. It sees that, but it's treating it as if it's a method. And it's just a simple variable. And since it's non-static, I could make it static. Let's make it static, so that should compile. But since it's non-static, it needs to know this in order to figure that out. Come on. Unsupported type. Yep, now that's come across as a... Wait a minute. That's not. 3880. I'm going to have a lot of stuff. Oh, this is when it's trying to listen for changes. Let's just not listen for changes. I really want to get this up in the 2 minutes I have left. Oh, run window again. Because I was passed a delegate. Now, this is a design decision on my part. I'm trying to force people to be a little bit more concise. If the function needs a delegate, I say you use a delegate keyword. I could also add an overload that accepts a function and converts it internally. And I think I'm going to do that because this isn't the most user-friendly thing. But I've got another this of type O, so I don't think I can just hack around it. 3990. Really? That's not. Controlled by is a separate thing. I must have written it's 38980. So this, by the way, is another kind of cool thing. You get a strut and it real-time updates the values in it instead of calling a delegate. So if you have a thing running on a timer, you can run back and inspect that. But anyway, I think this is at 3980. So what was the message again? Need this of type O. So yeah, I'm going to have to go into the guts of this and actually pass this along. And this is actually why I have the value pointer out here. So this is, it takes a type, then it takes a pointer to that type so I can work with it. And I have to do something very similar for this. you take the type, and then you take a runtime value of that type, and you use traits child. This isn't the right type, but it'll be that, and then the alias. And so what traits child does is it reattaches this value to a compile time entity. So that's the solution to that. And then you just have to pass the thing through the whole call chain. So that's going to take a little bit to set up, but I will come back to that and do it eventually because I am out of time today. I know I meandered a bit there. I spent half the time just talking about the Nintendo. But if you do have any more questions, feel free to hop on email. I'm adam.ruppe@gmail.com, or the DIRC, or the Discord, or the newsgroup at forum.dlane.org. I'm watching all those most of the time. So by all means, we love to have you and have a conversation. But until next time,